Hi everyone, thank you for joining us. Today presenters are Nacho Sainz, Senior Software Engineer, and Fabian Flores. Ooh, you probably know them. Fabian is a software engineer 3. So Nacho is a front-end engineer. He was one of the first engineers in the Nexiva Mexico office. He
What do
is
you got?
always
What do you got
learning
there?
something new
Huh?
and sharing that knowledge
What do
with
you got?
his team. Fabian is also a front-end engineer and has been with Nexiva for 2 years. He loves traveling and he's always looking for new resources to improve his skills. Sometimes when Fabian comes to the office, he brings donuts for the team. Really, that's amazing. He has the best recommendation for donuts. Today we will be trying, like as I said, a new Dead and Bytes. We will using the Kahoot, and yeah, it's a trivia website we use. So we hope you have fun and you interact a little bit more with this presentation. And please start clicking, playing with the Kahoot. Remember to respond on your browser or your phone if you're using it. And okay, that's all I got. Take it away, Nacho and Fabian.
Awesome. So, welcome you all guys here today. I think that we already had the introduction, but just to get the clarification, as you all know, this is going to be Typescript like for 10,000 feet ahead. We are going to discuss some points of why do you want to see if TypeScript is a good fit for your team or not. We are not going to get a little bit deeper on each edge cases of this language, but if that will help you to get some final discussion if that will be good for your team or not. So, if everything is okay, let's start. Nexiva, a Kahoot by Nexiva. Awesome. So, the main thing, how do you think TypeScript will change life is not going to be something like a bulletproof key. You need to have like the specifications that it will cover you and help you. And we will go to these 5 things that may think this is going to be like the basic we need to cover. The first part is why TypeScript appear and why TypeScript is helpful. Then we will cover a little more things that is more regarding to the language that are the types and interfaces. Then go to the classes that are something that allow us to communicate better with the backend guys to have the same interface they are using in the class for languages in this main thing. And at the end, we go with inference and narrowing. So let's start. The first question, what do you think TypeScript is? Let's add some music in the background. Doom, 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 doom. Mhm, 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 mhm. 3, 2, 1. Okay. A lot got the question correct, and another thing that JavaScript is a library JavaScript. So, just to clarify that, TypeScript is a superset of JavaScript or a language that has all the features that JavaScript already have, but the things that is adding to the language is the types. So the left image is something like a Pokeyoke that thing from Toyota that allows to see that only certain kind of things can pass to some parts. So for example, in this case, I want to get that reference to have like a function that is only going to accept some specific data in order to accomplish the behavior. We don't want to have an addition into strings for mathematical purposes. So that is one of the things that JavaScript was missing at the beginning. And the other part is inferencing, this thing that allows us to predict what we are trying to do in order to have autocomplete of code. That is going to be complementing with VS Code, because if you don't know, VS Code was developed by Microsoft. That is the same guys that are working with the TypeScript language. So, next one. How can we start using TypeScript into our first part of JavaScript? So if you don't know, there is a lot of things that JavaScript doesn't integrate it by common browsers. There was a part that, if anyone knows the JavaScript history, that Mosaic was the first part that we want to kill, and that's why we started working with Mozilla in order to start working to the standardization of how JavaScript will work across all the different browsers. And since that was growing a little bit rapidly, there was some tools created. And the first one that was like broadly standardized was Babel. And Babel allowed you to introduce a specific parts of the thing that you want to use. In this case, there are plugins for specific edge cases or a preset for a whole environment that you want to inject. And in this case, if you want to use all the environment for TypeScript, the recent version, then you just have to add that preset into your Babel configuration using Webpack or only the Babel configuration transpiler. Let's go to the next one. And just to give you like a brief introduction of what do you want to use, for example, the inference part that will autocomplete all the things that you want to use. Let's assume there is a particular item that is called corp account number that is saved in a global part that everyone needs to use. So the first developer will say, hey, corp account number is too long, so let's produce the string to have a standardized way of corp account number. That is passed to the next developer via Slack, and that will be a happy path because he will just say, I just use this variable that I got from Slack, and everything will work accordingly. Then the third guy is going to start reading all the base code that you have for the global store and find that he has to copy paste that in order to see that he had correctly that specific variable. And the fourth guy that they was just told by another random guy that he needs to implement that, he started writing corp account. No, that doesn't work. Corp account, no. Let's go to the Redux DevTools and then just find out what will be the right approach and then continue. So these things are going to be happening if we don't have the editors to tell us what are the possible ways we need to follow. And that's why that is a little bit helpful in order to reduce the time for searching for that specific variable name. Let's continue. And now it's the time for my co-host, Fabian.
Hey, everybody. Let's talk about types. Well, TypeScript is very special about types, as the name said. It has almost the same types as JavaScript, but it has a couple of more types, the special types. So let's talk about them. The string type, as JavaScript, it can store only text. The number this is special for TypeScript because the number wrap up all the options for the numbers we have in JavaScript. For instance, integers, floats, infinity, big ints, or not a number. All those types in JavaScript are inside the number type in TypeScript. We have the Boolean. We have the same in JavaScript. It just expects two types or true values, either true or false. The arrays is basically the same. It can store Booleans, numbers, strings, objects, dictionaries, and so on. The tuples, you can use tuples in JavaScript as well because it's like a pattern, and this pattern is you can think about if you need to have a list with specific values or in order. Let's say that in the first position of the array you need a string, and then you need a number and then a string. Then that is your tuple. You need an order, then that is a tuple. What else? We have the type literals. The type literals are kind of special because literally expects a value. For instance, the Boolean type, you can add the true value, and TypeScript expects the value as a true, and it infers that the value is a Boolean. Okay, so I will start sharing my screen I want to show you a little bit of the code in TypeScript to well to make sure that you are getting the idea of this language. So I want to share my screen.
Sure.
Um, the cover, I think it's this one.
Yeah, take over.
Okay, cool. So let me know if you can see my screen.
We can see it now, man.
Okay, cool. So as I mentioned before, we have the almost the same types in TypeScript. We have the string, we have numbers, booleans, arrays, tuples, objects, and literal types. And the example in here is we have this variable that is so true. So TypeScript infers that this variable has inside the true value, and it expects that this value should be true. So that is why this is a literal type, because we are just expecting a true value. If I add like a false value, well, I will get an error, and that will tell me, hey, this is not what I'm expecting. I'm expecting a true, and you're adding a false value. So this is like the idea for type literals. Um, so TypeScript has more values or more types inside, sorry. So, and one of those values is any. So any value refers to JavaScript handles all the types as any from the perspective of TypeScript. So all the values inside JavaScript are any's. So if you are like working on a project with JavaScript, and even though you have your arrays, lists, and numbers, then TypeScript thinks that those values are any's. So a good idea to use any in Java in TypeScript is if you are trying to move a project from JavaScript to TypeScript, then you should like take some time to move all the values inside your variables and adding a type inside. We have the unknown type, and this unknown type is super special, and I like to use this type when I'm trying to get information from the backend, because at some point I don't know what's inside this property, but maybe in the future this property will have um, a value inside that is a string or a number or a boolean or so on. So that is the scenario to add or to use unknown. When you are requesting something, then at some point you need to validate that the value you are expecting is the one or is the right one. So to use that, if you are using unknown, you need to validate that the value is the right value. And how to do that? Well, you need to create these statements, these if statements that sometimes are called type guards. Nacho will talk more about those type guards in a couple of minutes. But basically, the unknown value needs to be validated somehow, and this is the way how we can do that. For instance, if this unknown value has the value 10 as a string, then I need to be sure that it is actually a string. So with the type of keyword, I can validate that, and I will get, if I execute this unknown prop inside this if, now I am sure that this is a string. So I get all the functions that I allowed to use for the strings. So which is super cool, because you are like preventing errors in your code in a way. Okay, cool. And unknown values, unknown types and any types are called top types inside TypeScript. But we have one more type called bottom types, or like a is another type. And the name of that type is the never type. The never type is like if you had like a box of chocolates, and you, for instance, if I offer a chocolate to Nacho, and well, the box of chocolates is empty, so Nacho cannot get any chocolate at all. So that's the idea for the never type. And a useful scenario to use this never type is uh, you can just create a function where you are like validating the types of the type inside the possible type inside your never value, and then just add these exhaustive conditionals around the around your variables or something, and in that way you are sure that you don't have edge cases as much as possible, obviously. But if you at some point have trouble or if you add more values to a specific um, variable, then you will know right away that you are like adding a wrong value in your type. So that's the thing. The never value cannot hold anything, and if you have something in that never value, then you have something wrong in your code. Okay, so let's talk then about type aliases. Uh, Type aliases are the way we have in TypeScript to give friendly names to the types. I mean, all the types inside your application of the names of all the types are for you and for the developers that are working in the project. So that is the like the goal for the type aliases. So you can create more types or custom types in your type aliases. For instance, in this case, I am creating a type for person data, and I am adding the name and age property, which is a string and a number, and then I am adding a type to my variable hello object, and inside this hello object, I am expecting that a name and an age. Well, I am expecting a name and an age inside this hello object that data. If I remove the age, then TypeScript will complain because I am expecting this shape inside my object, and in this case, I am not adding the age. If I add again the age, well, I will get uh, the right declaration. You can declare types, custom types from the existing types in TypeScript. In this case, I am declaring the custom number type, which is just a wrapper for the number. So you can do this, but sometimes it's not necessary. I just wanted to mention this. But basically, I am telling in here, hey, this is a type called custom type, custom number type, but it's basically a number. So, well, I just wanted to mention this. The cool thing about the type aliases, so this is the feature that I love the most. You can add signatures to your functions. You can add shape to your functions. You can add like the parameters you need to add to that function and the return value if it has a return value. So this is how you can declare function signatures. You can declare a type. In here, I am adding a sum function signature name, and that expects two parameters, a and b, as numbers, and it returns a number. So when I declared my function with the signature sum function signature, then this function expects to have two parameters, and it returns a sum of values. If somehow I accidentally add this third parameter, then my function will throw an error saying, hey, this is not what I'm expecting. So you need to add only two parameters. And for developers, most of the time, when your project is growing and growing, you you find in a situation, then you don't know what's going on with some specific function, and if you don't add meaningful names to those functions, then you're in trouble. So TypeScript helps you with that because as we added the function signature, if I want to use my function, then TypeScript will complain if I call the function without those arguments that it's expecting. So it's super helpful TypeScript in these situations, because even though you didn't write the function, you will know the content or the signature of that function. So if I add like these two values, well, I will get the sum in here. So that is the first part of the type aliases. The second part is the unions and intersections. So first, unions are like, you can think about the unions as the logical or, because it's represented by the pipe. So that means that you can declare a type and you can add as much types as you want. If you, for instance, in this case, my union type is expecting a monitor, an instance of monitor or a keyboard. So that means that if I declare a constant, in this case union t, and I add my union type, and then I add an instance that is not inside this union type, then TypeScript will complain. So I need to add either a monitor or a keyboard to this constant. So let's do that. So okay, so now TypeScript is happy because, well, I am like adding the right type to this union t. And this is the most common, like type alias you will be using. The union types are super useful. I love to use them. And those are super helpful when you are like creating things in your project. The other part are the intersections, and the intersections are represented by the ampersand, and is like the logical and. You can combine several types in one type, and that's super cool. This is not common, but you can do it. For instance, I have this contact type with a name and phone, and I have this type friend with age and address. And then I created another one called contact and friend, and well, this type expects the combination of contact and friend. So I create this little function called get contact and friend, which expects a param, the type contact and friend, and I added here Nacho, phone 123 age. Sorry, Nacho, I don't know your age, and address. So if I go over here and I like write down this param, I will get the combination of the friend and the contact. So I have name, phone, age, and address. And if somehow I forgot to add a property inside this param, this argument, well, TypeScript will be super sad because I am not adding the right value. Cool. This is not very common to use intersection. I think I just used intersection once. So this is not very common, but it's good to know that it exists. One caveat about the type aliases is that you cannot redeclare the type. I mean, if you have the type in one file, you cannot redeclare the type in another file. So that's the only caveat I noticed in this kind of feature of TypeScript. But we have the interfaces. The interfaces are a little bit different because the interfaces are like contracts. If you want to have a shape in your objects that fulfill one interface, then this is the feature you should be using. The interfaces are intended to be used mostly in classes, because with interfaces you can extend interfaces or implement interfaces in classes, and you cannot do that with type aliases. Okay, so I love interfaces more than type aliases, by the way. And another cool thing is you can augment the properties inside an interface. That means that if you have an interface declared in one file and then you write the same interface in another file, well, you will end up with a combination of properties. You will be overriding the interface. So this is just an example. For instance, if I go over here with this ASD, let's add another name because I think I have already cleared this, something like that. So I have my interface in here. So if I create a property with the string ASD, then I add a name, and then I add age. Oops, age is another string, it's a number, and then I add something like this. Oops. Then my interface will be happy because now at this point the interface is the combination of these two declarations above. So it's a kind of like intersection type intersection, which is super cool. So that's pretty much more everything about the interfaces. And a good advice on when to use type aliases or interfaces is if you are going to combine or to use unions and intersections, then you should be using type aliases because you cannot do that with interfaces. You cannot create an interface like this, like interface, blah, 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 and then combine an interface with this. You cannot do that with interfaces. So if you are going to use union and intersection, you will be using uh, type aliases. And if you are writing a library, for instance, let's say that, I don't know, Next UI components is a library we are using here at Nextiva. And if you want developers to change the interface inside the Next UI components, then well, you should be using interfaces because you are giving developers the opportunity to add more properties to that type. And I think that's pretty much Nacho. If you want to go to the next topic.
Awesome. Yeah. And just before we continue, I don't know if you can take control of the screen again so we can have the presentation. And in the meantime, I just want to say that now that Fabian told us everything about how this is going to happen, we have some of the things that help us to see why is this going to be helpful, right? We are going to start documenting the code on how it's going to be shaping the whole things and how the data is going to flow across all the application. And that is super helpful because if we don't have to know all the developers in order to see what they were thinking when they start designing this code. And we know right ahead what thing we have access and which node. Okay, so continuing to the next one, and I think the next one because that was already spoke by Fabian. We have a quiz. Which are the two top types in Typescript? Hmm. 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 Awesome. So yeah, any and unknown. Just to clarify, remembering that any is going to be the normal behavior that JavaScript already has. And unknown is a semantic version of there is something like the JavaScript normal behavior, but we need to type guard or classify by paths what is going to be the specified type. Okay, that is already being covered by Fabian. So next one. Okay, so Fabian already told us that the interface are going to be the construct we have. So for example, we want to do this from one library to the consumer package or from the front end to the back end, meaning that we have some data that is going to come with a specific structure and we want to keep following that. So we are agreed that every part in the application is saving the same structure of that data, or in this case, because we are JavaScript developers, that specific object that was created. So classes are a way of, in ES6 modules, knowing TypeScript well before, that we can create the prototype change into the new way of JavaScript, meaning that all the things that you can inject are going to be in the specific object that you're going to to create with the new keyword, and any static file or method are going to be added into the prototype chain of that specific object. This was designed because we don't want to break all the other stuff that was created before. And just like a quick tip, if you didn't know, JavaScript was called Java before because they wanted to use like a Java language into the browser, and Brandon just say, hey, no, let's add some language that is easy for any developer to use and start just adding code without exploding anything. And that's why JavaScript is the way that it is at the moment. But since they started in that way and they encountered there are a lot of developers that wanted to implement classes, and then that's why they have to do this back compatibility, and it's not the same behavior we have in Java. But following that, classes are going to give us two things: the object that we are going to create using the new keyword, and also they are all going to be documenting types that we can use in any other object that we want to use. So for example, as Fabian was telling us of the interfaces, I can create a person class that is going to accept an initialized variable to the constructor that is going to be passed to that part. And also it's going to be documented what will be the specific types of each of the properties of that class. So we don't have to separate the declaration of the type and the declaration of the object creation into separate chunks of code. And that is super helpful in some cases, especially in the backend communication. Next slide. Quiz. When should I use interface or type aliases? I think Fabian gave us a helpful tip regarding that. Dum, 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 dum. Yeah, we don't want to use any word searching types. Just to be clear with that part, I will clarify any doubt regarding that at the end of the presentations. So now infer as to be a what in context of what will be the type, and as cons to narrow down a specific type. These two things are going to be the normal behavior of JavaScript that we want to follow. The first one is going to specify, based on the context that we are annotating our code, what will be the possible value that we are going to use. That will mean if we have an initialization of that variable, or the function is returning a specific type, then Typescript could say, hey, if we are following this path of this function, then it's going to not accept any parameters and it's going to return a specific number. But what happens if we want to say, I have this declaration for this specific string and this specific number to be returned from that function? Then instead of widening all the possible values that are going to be in that specific case, we want to narrow down to only the ones that we are specifying in that edge case, meaning that the function documentation of that part is going to say that we only accept that specific string and we are only going to return that specific value of the number. This helps us, for example, in the part of Redux, because if Typescript wants to infer the name of a constant that is a value of a string, then it is going to be possible anything that is going to be set in that part. But if we narrow an object down to be as const, then all the properties in that part are going to be set as that individual chunks of action types that we want to use. And then we can make some things like the return type for the create actions in order to see in our reducer what is going to be the chunk of action that is going to receive in each edge case, meaning that we have easier documentation of what values we have access on each type, and we can see what actions can we take from code in that perspective. So just to be clear, infer normal behavior of Typescript that will try to guess the value type of you are using, meaning that if you have a number and a string, it's going to have the OR type that concatenates those as a union, or as const that will say what will be the possible minimal value that I can infer for this specific code. Next slide. And that will be it for this presentation about TypeScript. I hope that you understand that this is going to be just like a 10,000 foot of the view of what we can do. But the main thing that we want to grab for you guys is this is a way from developer to document what will be the flow that we have and helping others to not check the documentation of Swagger multiple times or any other things to just get the value name of a specific property that you need. So, minimum of that, I don't know if you have any final words, Fabian, and if you don't, let's continue to the questions.
No, I mean, I am just reading the messages in the chat, and well, just if you are going to use any, well, just be careful with that, because you it can be your best friend or your worst nightmare. So be careful.
Awesome. So now what we want is you to type a word that was like the meaningful thing in this presentation for TypeScript. And that will be superset, great, language, the best, excellent. Someone put any, different, JavaScript, yes, superset. Awesome. Sorry if you hear my kid on the background, but he is not very happy at the moment. And I want to see if there is any doubt regarding TypeScript for the 10-foot long view. Anything that was not clear or you think you can clarify in this part, please write it on the chat or unmute yourself and ask to us directly. Don't be shy.
I have one question. What
Yeah.
happened with the default values that we have in a component? For example, if we have defined it these default values with prop types, what happened if we implement TypeScript? Exists a way to define these default values?
Awesome question. So now that we don't have we have the prop types, but using TypeScript allows us to define how will be the shape of those props that we're going to use and give us access into the intelligence of saying what will be the path that you need to follow in order to tackle those specific cases. But the main thing is that with prop types, you don't have any check of if you are using the correct value. That is only for documentation for the developers, but it's not applied at runtime. In here, the code is not going to compile if you are doing something funky that is not aligned to the specification of those types. So there are two approaches that you can use. One is set default values to the specific object that you are going to use and allow JavaScript to infer what will be the types of those. Or you can combine the assignation of the default value with the declaration type of a type alias and assign that to the prop that you're using in your component. I don't know if that was clear or you want to add a little bit more, Fabian?
Well, the cool thing about adding an interface or a type alias to a component, I mean that is the replacement for the prop types. But one of the cool things about that is if you have a property that is a function and that function has params, and then with the interface or with the type alias, you can add types to the params for that function, which is super cool because in that way you will know right away the type you are trying to use for that prop. And if that prop is a function and it has params, then you will know which params you need to add to the function.
Yeah, and also there is a combination, for example, the Redux library that allow you to say how it's going to retrieve the selector, so which value type you are going to receive in order to see what will be the following path that you need to check in your code of the component to have a correct answer following that. So Navarro just put a function declaration in the chat. Oh wait, Lance had another question. What if I want to keep shipping bugs to production? Can I keep writing JS or I'm obligated to use TypeScript and improve my code quality? Actually, this is one of the things that I want to see. If you don't feel comfortable using TypeScript, that is okay. But this is a tool to help us improve documentation. As you can see, the team is going larger and larger, and having this is going to be like a little more hard to get all the parts from one team to another without reading all the code and see the special request that you are doing, the shape of that value that will be returned. And to have this allow us to have an easy way to debug how we can do that approach. And if you don't feel 100%, but you still want to try, then you can just be pretty slow with TypeScript and allow you to set any in all the values. And that was some of the things that Fabian told us at the beginning. So you don't have to be forced to start right away with TypeScript, but slowly adapting how that is going to be documented.
Yeah,
Now,
I think.
go ahead.
Go ahead, Nacho. I think we have one more. When are we introducing TypeScript to the code base? Well, right now we have several projects running on under TypeScript. Most of them are inside Nextiva Connect. So we are using TypeScript, but the language has a bunch of rules. So you can use TypeScript with a few rules. So you will be writing TypeScript as if you were writing JavaScript, and that is our current configuration. We are using TypeScript, but um, somehow we are still using JavaScript because we are allowing to developers to use any's and all that stuff, which is not good at all. But well, that is like a kind of introduction of the language to the organization.
And now that I remember from Lance's comments, sorry to read it that out loud, but I thought it was safe. So if you don't want to move to TypeScript right away and you want to continue with JavaScript, there is an annotation called JSDoc in order to document all your code, but it's going to be a little bit verbose and you're not going to have that compilation check-in in order to see if you are following the correct approach. But in this case, we have the ability to see documented code, and that is one of the most valuable things that TypeScript can offer us. And Mr. Dimitri, if I use any in my code, do I have a chance of my PR being approved, or I need to merge it without approvals? So if you are not sure and you want to start using any for the beginner part, then yeah, you can use that part unless there is a clear way that we can introduce you to using some specific types. And actually, that is one of the things that I want to check with you guys. If you don't have to put a specific type to any part of your code, if JavaScript already infers that, because if we are going to we are not going to accomplish the dry concept that is don't repeat yourself. And in order to continue that path, we have to check if TypeScript already inferred correctly, and if not, then we need to update to match what we are expecting. Lance approved the JSDoc opinion. Alexis, we heard all the good parts, but are there any downsides when using TypeScript? Yeah, there is. As I mentioned at the beginning, there is no silver bullet. In this case, as I mentioned, TypeScript is a compiled language. So it is going to have a pre-compiled step before it could pass your applications to be run into the browsers, because currently all the browsers are not supporting TypeScript. And that's why we have this conversion part. It's going to be a little bit slower. So if you're going to be developing a larger application that is not really well divided, for example, let's assume that we are going to start using Connect without dividing any domain, then it's going to be a little bit hard because you need to recompile a lot of things that are going to be handling that. And also, there is a learning curve that you need to see the normal types that we define, the special generics that we didn't cover in this section, and another helpful things in order to have a very good documentation for your TypeScript. Downside, you have to write higher quality code, you and your. So yeah, this Just to clarify, there are going to still having some bugs. As I mentioned, it's not a silver bullet, but regarding the data is going to start lower it down because now you have access of how will be that structure and help you to see where edge cases are not covered. It's correct to say TypeScript and structure to JS. TypeScript adds types to JS. I don't know if that will be the same because structure could be from an architectural point or for any other thing, but TypeScript are safety regarding what data you are going to use in each case. As the first part of the presentation, it is going to be a poke joke of what parts are going to be on each specific code. Is unit testing similar to regular JS? It could be, but we can realize some parts to just be according to that because TypeScript is going to handle those without any concern. I'm going to put a library example. Let's assume that we are going to create a calculator that we want to see that we only accept numbers. And if we were using only JavaScript, we have to do some defensive programming, assuming that all the types can be a string or a null or a void. And in this case, we will have to say, hey, TypeScript, help us to say that these values are only going to be numbers. So we are delegating that so we don't have to put any defensive programming and we just care about the data flow. So in that case, we are going to reduce those types of testings. A question, so TypeScript gets compiled to JavaScript before it can be executed in the browser. Is that what Babel is for? Yes. Actually, all the code that we are currently using is downgraded to the version that we have in the browser list specification of what will be the supported browser for each case. Because we are using some features that are not available at the moment that are in the TC39 specifications, but not all the major browsers are implementing those. That is why we have to rely in some third-party library like Babel to assure us that we have all the things on each browser because as we know, the web is getting standardized slower, but there we have like that steady pace. Another question, can part of a project be in TypeScript and JavaScript coexisting? Yes, Fabian?
Yeah, basically, well, you are writing JavaScript code. And having JavaScript and TypeScript will depend on the rules you add to the TypeScript configuration. If you have strict rules, then you will be using mainly TypeScript. But if you have some rules enabled in the configuration of TypeScript, then you can combine both languages. Yep. But yeah, definitely you can do that.
Awesome. So I just put like a book reference that I really love that is in O'Reilly. So you have a O'Reilly account, go and read it if you are interested. And another question is, what is the most you can delete? I'm not sure I understand correctly that question. So I don't know if you can rephrase it so maybe I can have more context of what you were looking for. Okay. I think yeah. Awesome. Now that everything is clear and hopefully nobody has another question, I would like you to thank you all to come into this part. And Anita, I don't know if you have a final trivia.